Hey everyone, it's Colin. How's it going? I recently stumbled across a model of retro computer I used a lot back in my youth. This time, let's see what it takes to get this one working again. So I found this Apple IIe setup heading out for recycling, and I just had to grab it. It seemed complete but had a few obvious problems. First is that the ribbon cables coming out of the back were simply cut off. Someone was probably in a hurry to get rid of this. Second is that the permanently attached power cord on the monitor had been cut off as well. I'd have to deal with that before I could even test it. Cosmetically, it's in surprisingly good shape. When I found it, it was really dusty and I wiped it off before I even brought it home. There is a bit of yellowing, but for a 35-year-old machine, that's probably to be expected. Both the IIe and monitor had these security pads stuck to them, where a cable could be used to lock them to a desk. This suggests that the machine was owned by a business or institution of some sort, but we'll deal with those pads later. The inside of the IIe is in equally good condition, with not much dust at all. In slot 6 is a Disk 2 interface card. The IIe doesn't have any floppy drive ports built in, so you'd need a card in order to attach one, and this was the most common option at the time. It supports up to two 5¼ floppy drives, which are powered directly by the card. In slot 2 is an Apple Super Serial card, which allowed the use of something like a modem or a printer, and connects to a DB25 port attached to the backside of the case. And in slot 1 is an Orange Micro Grappler Plus card. While the SSC could support serial printers, this one allowed connecting a parallel port printer. Apple's own printers, like the ImageWriter line, were serial-based, but a majority of PC-compatible printers were parallel, so a card like the Grappler gave owners a better selection of printers to choose from. The first thing I wanted to address was the monitor power cable. The plastic plug it passed through on the back looked familiar, and it gave me an idea. I flipped the monitor face down and took out the screws that held the back cover on. While this thing probably hadn't been powered on in a long time, I was still very careful when working around the CRT. There wasn't much slack in the wiring, so instead of cutting it off before the plastic plug, I decided to pry the grommet apart. Then I could slide the remaining bit of jacket off the wires. One option could have been to simply replace the cable with another one, but I picked up an IEC socket instead. This is technically known as a panel mount C14 connector, and installing one would let me use a regular PC power cable, because permanently attached cables are annoying. The backside of the socket has terminals that can accept wires a few different ways, and they're labeled for line, neutral, and ground. Normally I would have gone with crimping on some insulated spade connectors, but the transformer inside the monitor is too close to the back to leave enough room for that setup. So instead, I stripped the insulation off the wires, slid on some pieces of heat shrink tubing, then looped the wires through the holes in the terminals. I fired up my iron and soldered the wires into place. I found that these took solder really well, so I easily got clean, strong joints. Then I could simply slide the heat shrink over the connections to insulate them. It was still a bit of a tight fit, but nothing to worry about, so I got the new connector screwed into place. If the wiring had been too short, I probably could have replaced it at the power inlet board, which incidentally reveals that this monitor was actually manufactured by Samsung. Something else I noticed was this label inside the back housing. It lists part numbers for replacement CRTs, but there's one that makes reference to an orange phosphor tube. The back of the monitor says this one has green phosphors, which is what I've always seen these monitors with. I had no idea there was an orange version. While there are a few electrolytic capacitors inside the monitor, none of them showed any signs of failing, so I decided to button it back up to give it a test. Thankfully, it powered on no problem, and even better, when I cranked up the brightness on the back, I got a picture. It was clear and bright with no flickering and no signs of image burn-in. I'm really happy with how this repair/modification turned out. It looks factory and, to me at least, makes the monitor much less annoying to set up and store because I can use detachable cables. And considering how perfectly that new connector fit into the back, I can't help but wonder if other revisions of this monitor came that way or if it was an option its designers considered. So with the monitor working, I could turn my attention to the IIe itself. The most common failure point in these is the power supply, so in the very least, I wanted to take it apart and inspect it before powering the computer on. If it had failed in certain ways, it could damage the IIe's motherboard. There's just a single 6-pin cable harness coming out of it, which is easy enough to disconnect. Then there are 4 screws that hold the PSU into the case from the bottom. This one was made by Aztec, and it's interesting to see the pinout and voltages printed right on the side of the case, which of course stands in stark contrast to the serious warning label on the top, declaring that it should never be opened. Yeah, screw that. There's 5 fasteners on each side holding the case on. This housing is made from aluminum and it feels really high quality. It's also interesting that there's no fan or cooling vents in it, probably because it's so low power that they aren't needed. This one only outputs 35 watts. Power supply efficiency has seen dramatic improvements since this one was made in 1985. You can get a modern PC PSU that delivers 1,000 watts and takes up about the same volume. There was one additional screw that confused me at first. It loosened, but never came out.
Oh. Well, I'll figure that one out later.
The internal components are pretty neatly laid out. Back then, it would be common to actually repair a power supply instead of just replacing the entire thing like we tend to do today. That extra screw turned out to be the connection for the ground lead, which was held in with a lock washer and nut. I needed to get the board out of the case to better inspect it, which meant taking out 6 more screws. I also got the wiring harness grommet taken apart so I could free it from the housing, then I was able to lift the board out. I had to set the housing off to the side since it was still connected to the AC socket, which I didn't want to desolder. And here's a sight we don't see on PCBs anymore. Notice how all the traces are curved? The layout for this board was likely hand-drawn. Using CAD to design PCBs was still pretty new in the 80s. The caps in this power supply, like those in the monitor, all look to be in good shape. No signs of leaking anywhere, and the tops weren't bulging. No doubt part of this is due to the use of good quality caps, like these Rubicons. But there was one cap I did spot for replacement, and it's a very common one to see in vintage computers. It's this AC input filter cap made by Rifa, and when it fails, it doesn't usually damage anything, but it does blow up in spectacular fashion and produce a lot of smoke and a bad smell. Failures seem to be a function of time and not just use, so when I spotted cracks in the casing of this one, that meant it was time to deal with it. Desoldering the old one was easy since this board comes from before the days of lead-free solder. New replacement caps are still being made, so I bought a few and dropped one in. A couple of quick solder joints later, and it would be good now for another 30 years. So with everything in the PSU looking good, I got it put back together, then reinstalled it in the computer. Okay, time to test things out. I got the monitor hooked up to the IIe, held my breath, and powered it on. Ah, success! I got the startup beep and an image on the screen. I could hit Control Reset to break into BASIC, then type out a simple program. The keyboard was working fine and even felt halfway decent to type on. The program ran, so things were looking good for this machine. And speaking of looking good, it was time to get rid of those security pads. They were stuck on with double-sided foam tape, and I was able to slowly pry them off with the help of a plastic spudger. These spudgers are made of a softer plastic than the case, so the risk of scratching things up was pretty low. Of course, a bunch of residue was left behind, so I scraped off the big pieces with the spudger, then used some Goo Gone on the remainder. One of my worries was that the area under the pads wouldn't have yellowed like the rest of the case and end up standing out. Interestingly though, that wasn't the case. It was just as yellowed, and in fact, in the middle, it had gotten even darker. I can only guess this was due to some kind of chemical reaction between the adhesive and the plastic. The last thing then was to deal with those cut ribbon cables on the expansion cards. I have no plans to connect a printer to this thing, so I don't need to worry about the ribbon coming off of the grappler card. But the floppy drive was something I wanted to take care of. I bought off of eBay a 20-pin ribbon cable kit. It came with a length of bulk cable and a number of connectors, so you could make your own ribbons whatever length you wanted. I slid the ribbon through the connector, making sure to align the pins correctly. I found using a bar clamp from the hardware store to be the best way to crimp these connectors on. It applies strong but even pressure. The direction of the connectors does matter, since these cables carry power to the drive. Get one end wrong and it can fry either the drive or the controller. So I made sure to copy how the ribbon was crimped on the original cable ends. To fix the other end, I had to disassemble the drive. This is really easy, just 4 screws in the bottom, then the metal housing slides off. The cable goes through a strain relief, then loops around a couple of ferrites before connecting to the drive's analog board. I figured that those ferrites were probably important, so I ran the new cable through them before crimping the connector on. These Disk 2 drives actually predate the IIe by quite a bit. They were designed in 1978 for the original Apple II by Steve Wozniak himself. They were considered quite the feat of engineering at the time because of their relative simplicity. Other computer manufacturers offer floppy drives, of course, but they all used more complex and thus more expensive circuitry. Woz had a reputation for making things work with the fewest number of chips, and this drive is definitely no exception. So I got the ribbon cable sorted easily enough, and there are lots of other tests and maintenance I could do to the drive's mechanical parts. But I don't really have any spare 5 1/4 inch floppies, and even if I did, I don't have any other systems I can use to write disk images to them. So for now, instead of using this drive at all, I picked up a really cool replacement, a Floppy Mu from Big Mesa Wires. As its name suggests, it's a floppy drive emulator. You load disk images onto a micro SD card and can configure it to behave like a few different models of drives. It's compatible with both the Apple II series as well as classic Macs, and includes a ribbon cable adapter for connecting to machines with DB19 floppy drive ports. It plugs into the Disk 2 card in the IIe just like the original drive, and gets its power from that interface too. You can navigate through folders of your disk images, then simply select the one you want to use. The display also shows activity, including the virtual track on the disk image the computer is accessing. Unfortunately, having real programs for the computer to run revealed a problem. When booting, some disks just threw an error message, and others simply froze. But sometimes the problem was more subtle, like when playing Moon Patrol, I couldn't get the vehicle to jump. I could shoot, so it was registering keyboard input, and I had confirmed earlier that all the key switches were working. The game just refused to acknowledge that the jump button was being pressed. And something similar happened with up and down. I couldn't control the buggy. What gave me an idea when troubleshooting was a different message that some programs would produce: relocation/configuration error. That didn't sound so much like a drive problem to me, so I powered the machine on while holding down both Apple keys. This kicks off its built-in self-test. And sure enough, it failed. Normally it should say system OK, but in my case, it was indicating a memory fault. Now, this isn't necessarily surprising. Even though they're solid state, it's not uncommon to see the RAM chips in vintage machines like these start to fail. Thankfully, the RAM diagnostic indicates which one is bad. In this case, it's the chip in position 12 on the motherboard. Unfortunately, I don't have any spares on hand, and proper replacements are becoming less easy to find. I bought some from a reseller in China for just a few bucks, but shipping is slow, so it's going to take a while before they get here. And that's where we need to leave this one for now. The voltages in the system look good and the capacitors show no signs of failure, so I think a bad RAM chip is all I'm facing. If that changes, well, I already have replacement caps on hand I can swap in. And otherwise, I'm pretty impressed by the condition of this system. Considering its age and that it had been dumped in an e-waste pile, it doesn't really show anything other than the signs of normal use. This specific setup also really brings back memories for me. In elementary school, the computer lab had about 30 of, well, these. An Apple IIe with monitor 2 and single disk 2 floppy drive. I remember having computer class once a week and playing educational titles like Number Munchers, Oregon Trail, and Carmen Sandiego. Whether this one came from a school, well, I don't know. There aren't any identifying marks or labels like you'd expect to see, and the general condition and lack of screen burn-in suggests it wasn't used a whole lot. My best guess as to this one's origin is something like a study room in a public library. But regardless of where it came from, it's great to rescue a piece of classic computing history like this one from the scrap heap. Yeah, it may still need some work, but that's just part of the fun. And as much as I learned from one of these back in the day, it's kind of fitting that I'm still learning things from it, even now. I'll likely do a follow-up when those RAM chips arrive, so keep an eye out for that. Until then, if you liked the video, I'd appreciate a thumbs up and be sure to subscribe. You can follow me on Twitter and Instagram at thisdoesnotcomp. And as always, thanks for watching.